Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new topic. In this topic we are going to study different types of realization technique. Basically this realization technique used in designing of filters. Now in higher semesters we are going to study different types of filters, same like a high pass filter, low pass filter, band pass filters, and many more things are there. Now at the end, basically we have studied in electronics also similar types of filters we have studied, but at the end we have to draw this circuit for a given structure or for given question. Similarly here also one equation or one system equation is given, and we have to design a different types of filters by using a different types of realization techniques. Now basically there are four types of realization technique. First one is direct form 1, direct form 2, next one is cascade, and last one is parallel. Now, but before moving to this realization technique, first of all we should know how to obtain that realization or how to obtain that graph. So first of all we'll see the equation and then we'll move on to the realization technique. Now basically we have studied the input and output relation or comparison between input and output, and it is represented in discrete time system as y of n equals to summation value minus of summation value m varies from 1 to n a m y of n minus m plus summation value m varies from 0 to m bm x of n minus n. Now where the n and m both are the orders, but n is the order of system and n is always greater than equals to m. This is the necessary condition. Now what I want, basically we want to plot the structures or different types of realizations which will gives us a comparison between input and output. So what we want, we are studying a ZTransform, which means we have to convert all this equation into Z domain. So what I'm going to do, I'll shift this summation part on left hand side to get the value of y of z. Now if we want to apply a Z transform, so first of all we want to open, or it is necessary to open the summation bracket or summation value. Now here the summation value varies from 1 to n, where this n is undefined. Similarly here also the summation value start from 0 to m, and here also m is undefined. So the equation becomes lengthier and longer. So to reduce this equation I'm going to consider my n value and m value both are equal to 4. So I'm going to substitute n and m equals to 4. My equation becomes now I'm going to open this summation bracket. So if I open the summation bracket, then this all m I'm going to substitute from 1 to 4, or you can say that I'm going to substitute the values of m from 1 to 4. So first of all I'll substitute 1. So this will be a1 y of n minus 1. Now I'm going to substitute n value equal to 2. So this will be 2, and this is also replaced by 2. Now I've substituted value of m from 1 to 4 in this equation. Similarly I'm going to here also I'm going to replace all the m from 0 to 4, or simply you can say break this summation value. So look at here on the right hand side also I've substituted the m value from 0 to 4. Now what is the next step? Just simply apply a Z transform on both the sides. Now I'm going to apply Z transform on both the sides. So all the y of n replaced by y of z. But look at here the function y of n is delayed by 1. If the function is delayed by 1, then place that delayed value or shifted value in the power of z. So I'll show you how to write the equation. This y of n is replaced by y of z. Next, first of all, the constant one, which is a1, and next one is this is shifted by -1, so we'll place this value in the power of z as it is, that is z to the power -1, into y of n. Z transform is represented by y of z. Similarly, do the same thing with the next values also. Now look at on left and right hand side. Here the x of n minus 0 is nothing but x of n, so z transform is nothing but of x of n is x of z. Now here also all the x of n's are shifted by -1, -2, -3 and -4. So similarly in this case also, if the y of n is really shifted by -1, then the z transform of y of n minus 1 is z to the power -1 x of z. So similarly x of n minus 1 will be z to the power -1 x of z. Now I'm going to take y of z common from left side and x of z common from right side. So now look at here, I have taken y of z and x of z common on the left hand side. Now look at it, I have taken y of z and x of z common from left hand side and right hand side respectively. So I have got this equation. Now what we want, actually I want to find out the transfer function, and for transfer function what we want, y of z upon x of z, that is the output in z domain upon input in z domain. So I'll shift this x of z on left hand side and the product of y of z on right hand side. And this is nothing but the transfer function of nth order, or you can say the fourth order function. So we have derived this equation for n and m equal to 4. We can derive the same thing for order n. So what will be the changes in this equation? I'll show you. So for nth order, this numerator will, of course, it will start it from 0. And the highest order is z to the power -n. In denominator also, bmz to the power -m. So using this equation we are going to obtain 4 types of realization technique. The first one is direct form 1, second one is direct form 2, third one is cascade, and last one is parallel. Now so first of all I will obtain a direct form 1 and direct form 2. Now so right now we are going to study a direct form 1 structure. Why it is called as direct form 1? Basically the name is given because you can obtain the structure directly from the transfer function of a given system. So direct form 1 and direct form 2 you can obtain directly using the transfer function of system. If the equation is given in the differential equation or delayed function, then first of all you have to obtain the z transform and then take the ratio of y of z by x of z, then you will get the h of z, and from that you can get the idea of, or you can get the result of direct form 1 and direct form 2. Now how to place this value in direct form 1 structure? Basically what is the direct form 1 structure? I'll show you. I'm drawing this equation only for n equals to 3 so that you will get the idea how to draw the graph. Well, this equation, first of all you have to break and then write this equation in terms of y of n and x of n, so that you will get the idea why I'm going to place all the a value negatively. Now do one thing, just multiply, cross multiply both the values. So y of z into 1 is y of z. Next, a1 z inverse into y of z. And on left hand side we have got this equation, and on right hand side simply multiply x of z with a numerator value. And now apply inverse Z transform on this equation. I'm going to apply inverse Z transform on both the sides of this equation. So inverse Z transform y of z is represented by y of n. Now a1 z to the power minus 1 y of z. Basically we have z to the power minus 1 y of z. So by using time shifting property, we can write this equation as. Similarly, we are going to write the whole equation. Now the next part, we'll apply inverse z on left right hand side. Now look at here, this is the value of m or delayed value, and it is 0. So if we are going to find out the inverse z, then x of z inverse is x of n. So b0 and z inverse of x of z is x of n. Next, similarly here also z inverse we have, so inverse z transform z inverse is always produces a delay, and here the delay value is minus 1. So my answer will be b1 into x of n minus 1. We'll solve next part similar to this one. Now what we want, basically I want equation for output, that is we want equation for only y of n. So what I'm going to do, I'll shift all these delayed values of y of n on right hand side. Now I have shifted all the delayed values of y on the right hand side, and now I have got this equation. Now why I have shifted this whole equation on right hand side? Because of the structure. In structure, all the a is carrying a negative sign just because of this equation. As we want only the answer of y of n, that's why we have shifted all delayed values on right hand side, and all the constant have right now a negative sign, whereas in terms of x of n, all the b values are having a positive sign. Now remember one thing, in direct form 1 we will always plot first of all x of n part, that is input part, and then we'll go for output part, and by adding whole result you will get y of n. Now I'll show you how to plot the direct form 1 structure. Now here we have x of n. Now what I'm going to do, I'm going to add these signals. This is the sign of adder where we can add at least 2 inputs. Now here we have x of n. Now basically this x of n is multiplied by some constant value, and that value is b0. So simply do one thing, just draw one block and write b0 inside it. Basically I don't have any space, so I have written outside, but you can write this inside, or the simple one, another technique is just add one more mark on it. Just mark one more straight line on this triangle, so that this will indicate that one value is going to be multiplied with this incoming signal. This is just one triangle. or you can say it is a device which will multiply incoming signal with some constant values, and this constant value you can write inside this triangle also, or just mark one straight line on it, or you can say connect one straight line on it and just write a value or constant value on this. Now next, here the x of n is delayed by -1, which means here we have to add some delay. So in Z transform we will always add a delay by adding one block, and that block is z to the power -1. And now simply multiply a constant value with this. The constant value is b1, so I'll write b1 inside this bracket and then place one more adder and connect these two adder with each other. Similarly do the next thing with this one. So this is only the input part. Look at here, in this input equation we have a total three delays. That's why we have added a 3 Z inverse block. When this block attach in series, then the orders or the functions or the particles always multiplied with each other, which is mentioned in that block. So Z inverse into Z inverse, what you will get? The bases are same, then orders will always get added. So at this point the order of Z will be a -2. At this point the order of Z is -3, and that will be multiplied with x of Z. Here also this x of Z, at this point x of Z is multiplied with Z to the power -1. At this point the Z to the power -3 is multiplied with x of Z. This is the representation technique. No need to write this x of Z, Z inverse, x of Z, Z to the power -2, x of Z, Z to the power -3 in our answer. Only just add this delay, and that value is total depends on the amount of delay added in input. Now similarly we'll plot the graph for output response, but mention important part is here the all the a values having a negative sign. Now first of all I'll plot n-1. Here the first delay is added, so we'll plot, or we will add one Z inverse block over here. And here I'm going to multiply the -a1 value with this buffer. Now how many delays we have to add? The first, second and third, total 3 delays we have to add. So which means we have to plot, or we have to place 3 Z inverse block in series, and that count is 3. Now depends on this we can plot the direct form to structure. Basically there is no more difference in between direct form 1 and direct form 2. What is the difference? In direct form 1 we required a number of memory elements. These Z inverse are nothing but the memory elements. Here we use total 6 numbers of memory elements, but you can say that if I keep memory element common for input as well as output, then you can say that the memory element gets reduced. So in direct form 2 our total number of memory element gets reduced. So we always prefer direct form to structure in next all the cascade as well as in parallel forms. Now I will show you how to write or how to plot the direct form to structures. Now if I take all the memory elements common, then we can say that we required only 3, because on right hand side we have a 3 memory element, that is delayed 3. Now on left hand side also we have a 3 delayed element, or you can say memory elements are 3. If I club both the memory elements and if I attach in one series, then you can get this idea basically. But look at it in direct form 1, on the left hand side we will always multiply all the buffer elements by b0, b1 and b2, or you can say the values of b which are constant. But in direct form 1 we'll always multiply the left hand side buffers by the values of a, like a0, a1 and a2, and on right hand side we'll place the values of b. So this is all about a direct form to structure. Same thing we are going to implement in cascade as well as in parallel, but how, I'll show you. Now in cascade structure, basically in cascade structure what we want, a series of functions, means if possible then try to factorize a numerator and denominator. How, I'll show you. Let's say after factorizing you may have this type of equation. Maybe after factorizing you will get this type of equation. Now what you have to do, in cascade format we want a different types of functions or transfer functions. Then I'll assume this whole part gives us one function, and the next part or next product part will gives us a second function. So let's say this one is my h1 of z, and next part is my h2 of z. So my h of z can be represented by h1 of z and h2 of z, a product basically. But what is h1 of z? H1 of z is nothing but 1 plus z bz inverse, and 1 in denominator we have 1 plus a1 into z inverse. And what is h2 of z? 1 plus b2 z inverse, and denominator 1 plus a2 z inverse. Now look at here, both the blocks h1 of z and h2 of z are multiplied with each other, which means in block diagram technique we have to connect both these blocks in series. How, I'll show you. But in cascade form and in parallel form we will always prefer a direct form to structure, because direct form to structure requires less memory element. Now look at here, in h1 of z we have a b0 value which is 1, so we will write here a b0 value which is 1, and next our b1 value is placed over here. Now in denominator we have a a1 value, but we know that we will always write all the a values but in negative manner, and this is my h1 of z. Similarly connect h2 of z in series. So here the value of a is a2, so I'm going to write a minus a2. Now on both the sides we have one delay, so we have used a one similar memory element, that is z inverse. Here we have value b2 and b0 value is 1 again. If you want then you can write, if don't then you can neglect this buffer also. And at the end we have y of n, and this is our h2 of z. So this is how we are going to plot the cascade structure. Only the thing is you have to factorize a numerator as well as denominator. Now I'll show you how to plot or how to obtain a parallel structure. Now, parallel structure. First of all, parallel structure you can obtain by taking a partial fraction. But before of that, we will write the transfer function equation. We will factorize all the denominators, and then based on that we will apply a partial fraction, and at the end of partial fraction what you will get, the result is in the form of, and so on. Basically these a1 and a2, a2 and a2, and a3 and a3 are not similar. These all are different values. Now as you have got this result, then this numerator gives us a value of b0. This is also a value of b0, and this is also a value of b0. Basically parallel means what? We are going to place all these three factors or all these three functions in parallel, where my in first block my b0 value is a, in second block my b0 value is b, and in third block my b0 value is c. Now I'll show you how to plot the parallel structure on this basis or on this equation. Now in first block we have the value of a1 and having minus sign, so we know that we will always place a negative sign while writing the equation or values of my a1. Now here the a value is already negative, so we will write a plus a1, and here the b0 value is a, so I'll write on buffer a, and next we will write the equation for b. Here the a2 value is negative, so while writing the answer we will always place a2 value plus. Now here in this part the b0 value is b, so we'll write only b over here, and at the end just club all these values by placing one adder, and you will get the answer of y of n. We have a series of these blocks, so all the series of these blocks will be added one by one in parallel format. Now why it is called as parallel? Because the first end and the last end of all the blocks are same. So similarly we are going to arrange all this format. Now we have studied a direct form 1, direct form 2, cascade and parallel. Now in exams they'll always give you one question. In that question maybe a transfer function is given or the differential or derivative equation is given. If a transfer function is given and if you want to obtain direct form 1 and direct form 2, then use a transfer function only. But if a cascade and parallel realization is asked, then try to factorize numerator and denominator. In case of parallel, go for partial fraction also. So that's all for now. We'll solve a numerical which is based on all these realization techniques one by one. So thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda. Thank you so much.